Hello guys, today I am going to give a presentation on graph theory. What is the use of graph theory in our real example? Or and today we will learn that okay, what is the use of graph theory in our day-to-day life. Like we are traveling all around the world or all around the India. So this is the use of graph theory. If we are working on anything, or that is a graph theory. Like there is a now I am going to say the definition of a graph theory. Graph GVE, where V and E is vertex and E is the edges. What is the vertex and edges? I will let you know in the further slides. So graph G is equals to VE, consists set of vertices denoted by V or by VGE and set of edges E or EGE. What is that mean? VE means vertex, V means vertex, okay, V, and E means edges, E. Okay, as I have told you in recent that ki we are traveling all around the world. That is the example of day-to-day example. If we are coming from our home to our office life, so this is also a graph theory which we are going to use. So these vertex, these are the points. It means if I am making a graph, these are the vertex, and to join the vertex, these are the edges. Okay, these are the edges. So by the definition of graph, what I have given there, written there, consisting set of vertices. Like this I am giving v1, v2, v3 and v4, e1, e2, e3 and e4. So vertices denoted by v or ve, consisting set of vertices. Set of vertices means the v is equals to v1, v2, v3, v4, v5, as we can take it. Okay, I have only v4, so we are taking v4, and edges is equals to e1, e2, set of edges, e3, e4 and e5. We are taking e4, we are taking the 4 edges. So this is the set of vertices, this is the set of edges. When these all are consisting, then it is a graph. Okay, when these all are consisting, it is called as a graph. As I have written here v5 and e5, so the graph is v1, v2, v3, v4, v5. Now the edges are connected through this. So this is e1, e2, e3, e4, e5. So at the first time, as I have written there, v1, v2, v3, v4, v5, and e1, e2, e3, e4, e5. This is the graph of 4 vertices, 4 edges. This is the graph for 5 vertices and 5 edges. So this is the definition. As I have given here, VG 1, 2, 3, 4, anything you can do it. Edges E1, E2, E3, E4, E5. Okay, this is the definition of graph. Now, edge type. There are two type of edges. We can say that, like as in the previous slide, as I have made a graph. Okay, I am making a 3 vertices and 3 edges. I am making 3 vertices and 3 edges. Okay, this is E1, E2, E3. Right now, to understand these two topics, directed and undirected. Directed ordered pair of vertices represented as U, V, directed from vertex U to V. It means U to V. This is the directed graph. U, this is V. This is the direction. Means you are going from U to V. This is a directed graph. Undirected graph, unordered pair of vertices represented as UV, and this we can say that you can say that UV and VU. This you have to write U then V, and for this you can write U, V or VU, because there is no direction. This is directed or undirected. The real use of directed graph and undirected graph is when the directed graph you are showing, there is no there is no you can say that there is a directed graph for the vertices. We can write UV and VU, and for the directed there is a we can say that there is use of directed and undirected. So we are going to in the further slides. So next topic is loop. A loop is an edge whose endpoints are equal, means this is loop. Okay, this is a loop, mean starting point and end point are same. Okay, this is a loop, and it for the degree, as I am saying that for the degree, all the in degree and out degree are stand for the directed graph, but there is no in degree and out degree for the undirected graph. So when we are calculating for the degree, so for the self loop, this is a loop, so it takes two variables, and for the undirected graph, it is also takes the two. I will show you from the example, okay, how to calculate the degree of a graph. Okay, this is the loop. Now next point is multiple edges. Two or more edges joining at the same pair of vertices is called as multiple edges. Now simple graph, this is a simple graph. Now I will explain here the degree of a graph also. Simple graph, it is an undirected graph. A simple graph consists of a vertex, and means we can say that we can define it, the graph is a non-empty set of vertices and edges where the ordered pair are distinct, means they are undirected. Like example, the graph have given vertex u, v and w, u, v and w, edges u to v, u to v, v to w, v to w, and u to v. This is a undirected graph. Okay, this is a simple undirected graph. How to find the degree of a graph? Degree of a graph, we have to calculate degree of a graph. So the degree of a graph means the degree of u, we are representing like this, degree of u, there is a two edges coming to the u. We can't say that this is the directed graph, so this is in degree, this is out degree, but we are seeing that you have two edges, so degree of u has 2, degree of v 2, and degree of w is also 2. But when I will take this is a directed graph also, we can calculate the other number. You can say it, I am taking the graph, this graph, only this graph. Okay, this is the directed graph of this graph. This is the undirected graph, this is the, so the degree to calculate, then the degree of u would be, the in degree of u is nothing, so in degree is 0 and out degree is 2, but the degree of v in degree 1 and out degree is also 1, and the degree of w in degree 2 and out degree 0. You can see the comparison for undirected and directed graph. We are calculating here in degree and out degree, and here we are not calculating the in degree and out degree. We are simply say that this is the degree of the vertex, and here we have to see the there is a vertex. If there is a loop here, then the degree change, then the degree should be for the degree v in degree 1 2 3, in degree would be 3, and the out degree is 1. You can see it 1 1 and 3 1. As I have told you, the loop, for the loop, key loop will contain only two variables. Okay, multi-graph, graph G V, V means vertex, set of vertices, and E means set of edges, consisting of a set of vertices V and set of edges E, and a function f from E. Function f from E is u to v. The edges E1 and E2 are called multiple parallel edges for function E1 and E2. Like there is a graph for given vertices u v w and edges E1, E2 and E3. E1, E2 and E3. These two are parallel to each other, so this is a multi-graph. E1 is parallel to E2. Okay, so this is a multiple graph. Next is directed graph. As I have given you previously, I have explained you what in the undirected graph, I have explained you the directed graph, but For this, I am telling you only the definition. GV is set of vertices and set of edges that are ordered pair of element of V. It means in the directed edges, like the graph has given in. Here I am taking only this graph. You can take any graph for the directed, as there is a triangle over being made over there. I will explain you for the square. A vertex, B vertex, C vertex, and D vertex. Okay, this is a graph. We can write the set of vertices V is equals to A, B, C, D. Set of edges, we are writing A to B because this is directed. Then B to D, no. Then D to B, D to B. Then D to C, D to C. Then C to A, C to A. This is the set of vertices for this graph as I have made over here. Okay. For now, we have understood that what is the definition of graph, what is the real world example of a graph. Then we are given the definitions of a graph. Then we are took the definition of a graph type, directed, undirected. We know till here we know the degree of a graph. For this directed multigraph consisting of set of vertices V and set of edges E and a function f from E to U to V is parallel to U to V. That is a vertex. Okay, and the edges E1 and E2 are multi-edges. Okay, the function of E1 is equals to function of E2. We are representing over here. This is a self loop. So this is the edge, the multiple directed graph E1 and E2 and E3 and E4. This is the self loop. Okay, so there are the 4 edges, 3 vertices. So these two are parallel to each other. So this is a multiple graph. Okay, multiple graph we can telling this one. So for the special cases, we are telling this one, and here special cases for the simple graph minus special cases. Okay, simple graph Kn is the simple graph that contains exactly one edge between each pair of the distinct. We are representing a complete graph. The definition of complete K1, K3, K4. We are seeing that this is a 1, this is a 2, this is a 3, this is a 4. This is a complete graph, means we are number of edges. Sum of degrees equals to number of edges. Like this is 2 vertices. So there is a 2. This one and this one. This is 3 vertices. 1, 2, 3. This is a 4 vertices. 1, 2, 3, 4. But for the calculating of number of edges, okay, for calculating the number of edges, you have to check. Here 3 vertices, here 3 edges, here 4 vertices, 1, 2, 3, 4, 5, 6 edges. Okay, so this is the method. So there is some more terminologies for the directed or undirected graph, like adjacent vertex. Adjacent vertex, if 2 vertices are joined by the same edge, they are known as adjacent vertex. Then adjacent edges, if 2 or more edges are incident on same vertex, they are known as adjacent edges. Degree of a vertex, the number of edges associated to a vertex. A loop contribute to that. I am explaining a number of edges associated with vertex. A loop contributes twice to the degree, as I have told you, twice to the degree. Okay, for this there is a graph over given here. A vertex V, U, V and W, and edges is given here. So how to find the degree of U? Degree of U is 2 because this 2. Degree of V 1. Degree of W 1. Degree of K 0 because K haven't connected with any edges. So this is the degree of a graph. Now the pendant vertex having means the degree would be 1, then it is a pendant vertex, and the isolated vertex, the degree would be the 0. It means the K is the isolated vertex and V is the pendant vertex because its degree would be 1 and its degree would be 0. So it is a pendant vertex, and this is the isolated vertex. Next, for the directed graph, For the edge UV is adjacent to V, or it is adjacent from U to V, means U is the initial vertex and V is the terminal vertex. In degree, number of edges which comes for U, it means it comes through the initial vertex, and the out degree, the number of edges for which U is initial vertex. It means I'm saying the in a simple word, in degree means how many edges is coming to that vertex. Outgoing means how many edges is going from that vertex. Okay. For this graph U, V and W, there is a vertex and the edges is given U to V, V to W and U to V. Okay. U to W here, U to W, this is okay, U to W. Now the degree of U, okay, the degree of U means here the out in degree is be 2 and out degree would be 2. Okay. The for V in degree is 1 and out degree is also 1. Here it is written V in degree is 1, out degree is 1. And for W in degree is 0, in degree is 2, sorry, in degree is 2 and out degree is 0. देखो इससे कोई गया ही नहीं है, तो this is that one. Now for this, now till here we have learned about the complete graph and types of graphs. So this is a bipartite graph. This is also comes under the types of graph. In a simple graph, if V is partitioned into two disjoint sets V1 and V2 such that every edge in a graph connect a vertex in V1 and a vertex V2, so that no edge in G1 connects either two of vertices V1 and two vertices V2. Like we are saying that this is the vertex, this is the given vertexes V1, V2, V3, and this is another V2, V4, V5, V6. So this is the bipartite graph. I am taking an example of bipartite graph. Okay, like this. I am taking a graph. Okay, x1, x3, y1, y3 and x4. Okay, this is the graph. Okay, here are the vertices. Now for this, for the bipartite graph, we have to partitioning the graph. So for that, I am taking this is the given vertex like x1, x3, y1, y3 and this is x4. So this is the connected. So we are partitioning this graph for x2 and y2. If we are partitioning this graph, now the bipartite graph says that we can't connect to the adjacent edges. We have to connect for this. So I am making the solution for the bipartite graph for this x1, x2, x3, y1, y2, y3 and this is x4. Here have, so we are connecting this and this. So as I have told you, you can't connect the adjacent edges, but we can connect this is a bipartite graph. Okay, for this graph, this is the bipartite graph for this graph. Okay, you can understand for there. Now the next is complete bipartite graph. Okay, the complete bipartite graph, if Kmn is a graph has its vertex set portioned into two subsets of m and n vertices respectively, there is an edge between two vertices if and only if one vertex is in the first subset and other vertex is in the second subset. It means you can say this is the example of K23 means this is two vertex, this is three vertex. Okay, these two are connected with these two are connected with all three. This is connected with this is a complete bipartite. You can say that you can see that the adjacent edges are not connected with each other. You can see these two are adjacent to each other, but this is not connected. So for this K33, this is the complete bipartite graph. Okay, this is the example of K22. This is K33. This is a complete bipartite graph. Okay, now the next is subgraph. Subgraph, what can we say? That a graph whose vertices and edges are subset of another graph. For the definition, as I am saying, this is a graph. Okay, A, B, C, D, E, these are the edges, and these are the vertices, and these are the edges. So C to D, this is a one part of a graph, and we can say that this is a subgraph of a graph. Okay, it means it is a subset of a graph. Subgraph is, we can say that the vertices and edges are the subset of a graph. Okay, we are taking the example. This is a graph. Okay, A, B, C, D, E. This is a graph. We can say that A, C, D, E. This is the graph 1, and A, B, D, graph 2. So these are the subset. We can take also this one, A, C. This is also a subset of a graph. We can take any one for the subgraph, subset. Now, the most important thing coming under in the graph theory is a graph coloring. So there are two types, vertex coloring and edge coloring. So we are learning here the graph coloring for the same. So what is the graph coloring? Coloring of a graph constitutes coloring vertex edges of a graph. So I am explaining for that one. So this for graph coloring, and coloring for all vertex of a graph is a property that no two adjacent vertices have the same color. For the coloring of a vertex, for the coloring of a graph, we are choosing three steps. For so these rules come under the steps for that. It is come under the second rule that we have to color all the graph, but the adjacent vertex are not same color. Okay. So for this, we are taking a chromatic number. For the coloring of a graph, there is a topic comes under for the chromatic graph. Chromatic number. The chromatic number defined as the minimum number of color needed for the coloring of a graph. Like we have to check the less number of graph the less number of numbers should be the use for the graph coloring. For the chromatic, to find the chromatic number, there are three steps. First, you can take any of the vertex. You can start any of the vertex, and you can give any name of the graph and number. You can start. But second rule is that you can't color for the adjacent one. So this is the written. So this one is a graph for chromatic number 3. This is the red. Okay, so this can't be the red. So blue, and this is red because this is not adjacent one. This is green. So this is the chromatic number. We are finding this one, and the planar graph is saying that it can be plain without any edges is crossing, like this. This is a graph. Okay, so this edge is crossed, but we can make it this one. So we can do this and fit this. Okay, this is a planar graph. Okay, thank you.